Hello, welcome to this lesson of our study of calculus 1. So in this lesson we just go through what we mean by differentiating from the first principle. Okay, so we just take examples of such questions and then solve them. Okay, all right, so let's start. If you have not subscribed to the channel, kindly subscribe to support the channel. Okay, all right, so differentiating from the first principle. So if a function is differentiable, okay, then we call it differentiable form, or when you differentiate you call it f prime of x, or you can say d dx of f of x. Okay, a function that is in terms of x. So is that, and is given by, in the first principle, is given by the limit as h approaches 0 of this whole thing. Okay, f of x plus h minus f of x over h. And now with this, the h is actually equal to change in x. Okay, so in some books they call it change in s delta s, others too call it like this, sigma x. So people can be using other form, but I use h. Okay, so you can see it either h or delta s or sigma s or whatever you want you meet. Just know that it's just a change in the s coordinates. Okay, we could have proved this, but then time is not on our side. It's very simple. Okay, it's very simple to prove. You can try to sketch this. You have a function that is both on the y and x axis. So let's say if I have x1 here and I have x2 here, okay, the function x1 will correspond to a point here, which is the y, and at that point you will call it f of x. Okay, and when you increase from x to x2, x1 to x2, okay, that will be just the change between this. So that will be the change in x, which is the h, and you move from that. It means the function f of x will move from this to this f of x. So let's call it f of x1. Let me put it that way. So you move toward f of x2. This will be the point. So at this point we'll get another y2, let's say y1, y2, okay, which will be f of x2 here. Okay, if you know what I'm trying to say, it means it's like this. Okay, and this is also like this. So if I want to check the gradient of this one, the gradient is just y2 minus y1 over x2 minus x1. Okay, that is a proof. Let me try to go through it quickly for you to understand. Okay, I hope you remember the graph. Okay, so with such issue you could see that y2 was actually equal to f of x2. Okay, and in terms of the graph, we said x1 was here and x2 was here. Okay, so I can write x2 in terms of x1 because we said the difference between them was h. Okay, if you remember, so it means that x2, before you can get s2, is the same as x1 plus h. When you move from here 0 to x1 and you add h to x1, you get x2. I hope that is okay. So I can say that, okay, fine, let's say that y2, okay, let's say that y2 is now equal to f of x1 plus h. Okay, and then y1 was actually equal to f of x1. Okay, so we have x2 minus x1, and x2 minus x1 to be equal to h. That was the difference. Okay, so when you put it inside everything, the gradient function, I mean this function, okay, this one, the gradient function, what will we get? Okay, so let's try to do it here. So the gradient, which is m, will be equal to f of x1 plus h minus f of x1, okay, over x2 minus x1. Okay, so with this, let's try to say that m will be equal to f of x1 plus h minus f of x1 over h. Okay, but if we assume that for every point on a graph, okay, so the graph was supposed to be like this, x1 is here, and then f of x1 was there, and f of x1 plus h was there. So for every line or for every point on this line, the gradient is the same. Okay, so we can generalize the x1 and call it, let's say, x. For every x you pick, the gradient is actually equal to f of x plus h minus f of x. Okay, it's just for every x you pick. We are trying to write it as a function, okay, like this. Now the question is, what will be the value of this when h is attaining to 0, when h is become very small? Okay, when h is trying to become very small, okay, I like to erase. Okay, I'm sorry, let me put it back so that when you want to do a recover, you can get this. Okay, so when x is very small, when h is very small, meaning that the difference between, let's say this was x1 and x2, when we are considering a distance between x1, let's say I pick an x2 which is here, okay, which means this will go, and it means the gradient or the h, the difference between them will be very small. Okay, what will be the value of f of x plus h minus f of x over h? So as h is approaching very, very small, something like 0, it means you have to use a function that we know, and we call it the limit. So when h is approaching 0, what will be the value of this? So you find the limit as h approaches 0 of f of x plus h over that. Okay, and now this tends to become the gradient, and this is what we call differentiating from the first principle. So it's nothing new to you, it's just from the gradient equation. Okay, so if you have a function and you want to find the derivative of the function using first principle, then this is what you have to use. Okay, the idea of gradients. Okay, so let's pick some examples and try to go through them. So find f prime for f of s equals x. Okay, now we know other people knows how to do differentiation, I know, but we'll show you the way. But then let's try to go through, use some derivatives using the first principle before we start with the normal one. Okay, so with f of s equals that, we said you have to evaluate this as h approaches 0 of f of x plus h minus f of x over h. So with this function, f of x plus h will be equal to just x plus h, because f of s is what? F of s is equal to x, so it means f of s plus h means wherever I see s, I put x plus h, and these two have been given, and then what I have to do is just put them inside this limit function. Okay, so it means that I'll have limits as s approaches it's h actually, h approaches 0 of f of s plus h, and that will give us what? S plus h minus f of s, which is x, over h. Now this is equal to limit as h approaches 0 of x plus h minus x, and that will give me h, because x minus s will give me 0. So it means that I'll have limit as x, I like writing x, right? h approaches 0 of 1. Okay, and we said the limit of a constant is still equal to that constant, so it means that the derivative, which is the f prime of x, will be equal to 1. And indeed, if you use that method, you get 1. Okay, of the function f of s equals x, this function. Okay, all right, so you know the derivative of this. Let's put it in mind, and let's go to s squared. Okay, find f prime of x. So with this, we need f of x plus h and f of s. F of s is given in the question, so all that we need is f of s plus h, which is equal to x plus h all squared, and that will give me s squared plus 2xh plus h squared. Okay, so with this, all I need to do is try to find the limit as s approaches, limit as x approach is h approaches 0 of f of s plus h. Okay, let me write it here, minus f of x all over h. So limit as h approaches 0 of f of s plus h is what? S squared plus 2xh plus h squared minus f of s, which is s squared. Okay, all over h. Now with this, we have limits as h approaches 0 of Now let's try to cancel some terms. S squared is here, and you cancel minus S squared, so it means I'll be left with only 2xh plus h squared. Okay, so I have 2xh plus h squared over h. Okay, and this will be the same as limit as h approaches 0, okay, of 2xh over h plus h squared over h. This is how fractions are being done. Okay, and now this means we'll get limit as h approaches 0 of this. Will take this off. Okay, so let's try to use another pen. This will take this off, and this will take one of these off. Okay, so we'll be left with only 2x plus h. So now you can put a 0 inside h approach. The reason why we don't normally put the 0 inside is because of the denominator here. When you have the denominator h as the denominator and nothing is cancelling, and it is the only denominator, when you put 0 there, this wouldn't be existing. Okay, that is why we try to simplify it and get an expression that when you put 0 there, it will be existing. Okay, so we'll have 2x plus 0, which will be equal to 2x. So it means our f prime of x, or the derivative of s squared, is equal to 2x. Indeed, we use that method and it will be equal to 2x. Okay, so let's try to solve this as well and see. When you have this, what happens? Okay, that's the third question. Now all that we need is f of s plus h, and that will be equal to 1 over x plus h. Okay, so limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so this will be limits as h approaches 0 of f of s plus h is 1 over x plus h minus f of x, which is 1 over x all over h. Okay, now the whole of this will give me limits as h approaches 0 of, now let me try to simplify the numerator. Okay, this fraction, if you want to solve this fraction, is simply 1 over x plus h minus 1 over x. Okay, so first of all, this multiply this and you get x minus the whole of this multiply 1, and I'll have x plus h all over the product of the two denominators. Okay, that is how you solve it. So the numerator will give us x minus x plus h all over x into x plus h, all of the whole of this, okay, divided by h. If you remember, this is what we had, so it's all of them over h. Okay, so I'm just writing it divided by h, and here will give me limits as h approaches 0 of x minus h over x into x plus h, okay, times 1 over h. If you remember, when you are doing division by a fraction, this is what you do. Okay, this is how this whole thing will turn to multiplication for us to be able to do it. Okay, so you get limit as h approaches 0 of s minus s is 0, so I have minus h over x into x plus h, okay, times 1 over h. And now this becomes very simple for us, so this h will take this h off and we'll be left with minus 1 here. Okay, so it means we'll have something like this: limits as h approaches 0 of negative 1 over x into x plus h. Okay, now you can put h equals 0 inside this because we won't get infinity or non-existing expression. Okay, so this whole thing will give me negative 1 over x into x plus 0. The whole of this will be negative 1 over s squared. So f prime of x, which is the derivative of s squared, 1 over x, is minus 1 over s squared. Okay, indeed that is true. All right, so let's move ahead to a very complex one. Okay, so you're supposed to find the derivative of this whole function. So this is a whole polynomial function, okay? The other ones we were doing were polynomials, but the other terms weren't present, okay? But here, all the other terms are present, okay? So to know this, all of what we need here is f of what? X plus h, okay? F of s plus h. And with f of s plus h, we know it's equal to wherever you see x, you put s plus h there, okay? Squared minus 3 into s plus h plus 7, okay? So here, if I express it or simplify it, I'll get s squared plus 2xh plus h squared minus 3x minus 3h plus 7, okay? Now with this, let's try to put them here. So I have limit as h approaches 0 of f of x plus h minus f of x over h, okay? So here we know everything, so let's try to go ahead and do f of s plus h minus f of s somewhere, because this is very complex. We can't put them together there, okay? Or if you want, we can still do that, okay? So I have limit as h approaches 0 of f of s plus h is what? S squared plus 2xh plus h squared, okay? Minus 3x minus 3h plus 7 minus our f of x, which is s squared minus 3x plus 7, okay? All over h. I hope you can see, because it's very, very long, okay? So I'll have limit as h approaches 0 of, I have s squared here, okay? I have s squared plus 2xh plus h squared minus 3x minus 3h plus 7 minus s squared plus 3x minus 7, okay? All of this over h. So let's try to do some cancellation here. I have s squared minus s squared here. I have minus 3x, I have plus 3x here, I have plus 7, I have minus 7 here. Okay, so all that I'm left with here is only limit as h approaches 0 of 2xh plus h squared minus 3h all over h. That's what I've been left here. And so we can use our idea in fractions here. So this tends to limit as h approaches 0 of 2xh over h plus h squared over h minus 3h over h, okay? So this whole of this will then be limit as h approaches 0 of 2x plus h minus 3. So you put 0 in place of h, and this will give us 2x plus 0 minus 3, and this is equal to 2x minus 3. So it means that our dx of f of x is equal to 2x minus 3 from first principle, okay? Now let's take the last question from first principle, and we'll be able to solve every question, every polynomial question in how do you call it, first principle, okay? So after everything, I'll give you an example to go and try, okay? All right, so with this, what you have to do is first find f of x plus h, and with that it is equal to square root of s plus h, okay? So I have limits as s approach, sorry, I like writing x, okay? Please forgive me. Limit as h approaches 0 of f of x plus h, okay, minus f of x over h. This is what you want, and this is limit as h approaches 0. Now if s plus h is square root of s plus h minus square root of x, okay, that is our f of x, then over h. So how you solve this is simply rationalize the numerator. I've already told you that you can rationalize the numerator as well, okay? So the conjugate side of the numerator is just square root of x plus h plus square root of x, okay? So you have to multiply both the top and down by that, and this will give me limit as h approaches 0 of square root of x plus h, okay, minus square root of x over h times square root of x plus h plus square root of x over square root of x plus h plus square root of x, okay, like that. So the whole of this will give us limit as h approaches 0 of, the numerator will give us difference of two squares, okay, like that, squared, or you can expand it the way you want to expand it, okay, but this is how I've seen it. So you can take your time and multiply both numerators by themselves, and you get what I'm trying to get, I'm coming to get here, okay. But if you can see the difference of two squares I'm doing here, that is also okay with you, okay. So h multiplying square root of x plus h, okay, plus square root of x, and now this will give me limit as h approaches 0 of x plus h minus x over h into square root of x plus h plus square root of x. Now we have to cancel some terms, okay, so x can cancel minus x, and then we'll be left with h over that, okay. So we have limit as h approaches 0 of h over h into square root of x plus h plus square root of x, okay. And now h can take h away, and we'll be left with 1 at the numerator. So we'll be left with limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. And now we can put our h equals 0 inside, and this will give me 1 over the square root of x plus h, that is plus 0, plus square root of x. This will be equal to 1 over square root of x plus square root of x. So the whole of this will be equal to 1 over 2 square root of x. That will be our f prime of x when f of x equals square root of x. When you differentiate, this is what you get, okay. All right, thank you, and don't forget to subscribe to my channel. In our next discussion, we'll talk about how to differentiate trigonometric functions like sine of x and cos of x using the first principle, okay. See you next time.